A very good afternoon to all the dear friends. Very good afternoon to all my dear friends, colleagues, water professionals, faculties, students. I think every Sunday we try to host some of the distinguished professionals who come at our platform and deliver their expertise, experiences, their wisdom to our listeners. Today, our distinguished guest is Sri Harish Hingorani, sir, who is having a vast experience in drinking water and sustainable kind of system. He worked across India, and we are lucky enough to host him here for the today's session. And our purpose is just to uh, create the learning across learning attitude and across India among water professionals, students, and that is the our purpose for such kind of lectures. So I would welcome Harish sir. Harish sir, hope you are here. Yes, please, sir. Over to you, and kindly join us, and you can start the session.
Thank you, Maneesh. Basically, drinking water is a major challenge nowadays in the country. So I will divide drinking water sector in three pillars. One is a planning, second is a implementation, and third is a O&M. So today mainly I will put a stress on how to ensure sustainable planning of the drinking water supply system. If your planning is incorrect, naturally your implementation is going to be a problematic, and sustainability of O&D will be a major challenge. So I will,
You have you shared your PPT, sir?
yeah, surely share.
Yeah, I think no, no. I think it's not visible to our.
This is okay.
I think
It's
yes, yes.
visible.
Now it's okay. Yes, yes, yes. Now, sir, you can
So
start.
you see, I am talking on the sustainable planning only. And issue is the climate adaptation, which is a major challenge across the country. The mainly source of the water supply scheme is facing lot of challenges in terms of quality as well as quantity. Demand is increasing and resources are decreasing. How to ensure the sustainability of the system as a whole under the consideration. So we'll be talking on source sustainability, system sustainability, and everything here. And ultimate aim is the reliable drinking water serviceability. So how to ensure the provisioning of safe and potable water at each household. Next. So basically, in the country, we are running two programs. One is drink from the tap for the Amrut 2 and urban water supply scheme, and Har Ghar Jal, that is a functional household connection at every household level. Basically, aim of the both the programs is same. You see, we have to ensure the safe and portable water across the each household. This is the and would ultimately reduce the waterborne disease. So water quality is a major challenge. So you might have heard about for last 1 month indoor challenges in the water quality. So we will little because it is a vast subject. So we cannot go in detail, but at least I can highlight the things. Uh, we can talk of some little solution also. Next. So basically, what is the SMART goal? I defined it. Goal should be very specific. Okay. Whatever you design, this is not only for drinking water, but your goal should be very specific. Goal should be measurable. Says, I need safe and potable water. So I define the quantity as well as water quality. right? So you can have an IoT monitoring system to ensure the service delivery. So this is a measurable, right? What is achievable? So basically under 73rd and 74th Amendment of the Constitution, our systems are required to be operated by the local bodies, oblique PRIs. So we have to act as a technical assistant to them. Funding you can get from center as a center. So achievable, you can achieve the source. I am hitting the source sustainability everywhere. So source sustainability is a major challenge to how to ensure the source sustainability, and again affordability of O&M, which is a challengeable because if we my O&M expenses are high and revenue is too low, how to meet the gap funding and relevance. We should talk about the SDG, and I am bringing in some new thing, that is the ESG principles are required to be embedded in the water supply system to ensure to ensure the portability of the water. So ultimately, we need to switch over to the solar power solutions, may be helpful in the sustainability of O&M and minimizing the carbons. So we'll be talking on the source recharge, adopting scientific planning, and water safety plan as desired by the WHO. So again, you can fix the time bound period to ensure the completion of the systems as government desires. Next. So basically, what we had talked under the 73rd, 74 amendment, the core requirement is water supply should be a demand-driven principle. This is a key. Ultimately, aim of demand-driven principle is to ensure sense of the ownership by the community. IEC play a major role, you know. Ultimately, we can achieve the willingness to pay through the IEC, and aim is to ensure the sustainable O&M and ultimately need to strengthen the local bodies of PRIs for the technical purpose, for the financial purpose, and we need to have a community-led governance. This is the most important focus of the both the programs, right? So I am talking here on the focus on the main sustainability with the least cost solution. We'll see in next slides. So this is to my experience of the vast experience of 54 years, mainly lack of the clarity in the planning norms. Mostly in some cases, what we have found, guideline suggests the things in between cup and lip, not beyond that. It should be very clear. I will be talking there. Guidelines should be very clear and user friendly by the grassroots workers, maybe sub engineers or junior engineers, assistant and executive engineers. So if it is there, if they can understand, they can drive the program. And I will further add, being a water as a state subject, so there should be a state specific guidelines too should be in place. Mostly what is a JJM guideline, CPHO manual, they are only simply national guideline. They are the guidance purpose. State should come forward with their own recommendation with the site specific needs. So I have highlighted, in the absence of target oriented framework, effect effect of water supply system has been weakened, and mostly what I have talked, decentralized demand principle was often overlooked as suggested, but mainly it has been taken over by the demand driven supply, not by the you see planning process lacking the meaningful community. The key challenge I have seen in the field as a JJM task force member, and also with the Amrut 2 schemes, I used to have a lot of visits. So basically, community not being basically engaged. what are their requirements, what they want from us, because they have to pay the money, they have to manage the water supply system. So we need to have appropriate institutional arrangements in place that has to be ensured. And ultimately, the absence of planning design standard, a borewell recharge, especially I'm talking, because rural water supply and small water supply schemes are based on the groundwater source. So we can also talking on the how to ensure the groundwater source sustainability and ultimately replicability is key. Further, if you find the JJM guidelines, page number 54 and 55, JJM mentioned the use of the hydrogeomorphology. The drinking water ministry has done the really excellent work getting developed hydrogeological maps from the ISRO way back from 95 to 2000. Most, almost 70% of country has been covered. Really, they are having 16 parameters. You can further get it optimized from the ISRO too. So, but issue is how to use how to use these AGM maps. It has been never come in the picture in the guidelines. This is a key challenge, and I will show you. We have developed some framework with the help of ISRO and demonstrated in the Chhattisgarh. Again, I will talking on the sustainability of O&M remains to be a key constraint. How to achieve, because it is to be managed and operated by the local bodies, which need a major capacity building. So further guideline further highlighted not only the JJM but also CPHO manual suggests and recommended the use of the solar water energy, solar water pumping, or solar energy for the big schemes to ensure the to minimize the to optimize the cost of the O&M at large, because O&M cost mainly covers the 60% or 70% of power bills. So you can optimize using the solar cell, but really detailed guidelines, especially in drinking water sector, are missing, which we can try to develop the same with the examples I can talk on further. And appropriate selection of pipe materials is a major challenge across the country. Mm, Without considering the CPHO manual guidelines, pipe selection is governed by the vendor-driven technologies. Further, because there is a huge rush of the work with the state departments, so they have no control on the quality assurance. So substandard materials have been used, are being used, which need to be taken care of. And poor workmanship is a major challenge, ultimately impacting the service of the system and without considering life cost approach. So we need a robust quality assurance, which about few days back has been talked in the JJM2 program. Quality assurance has been given a top priority, along with the how to ensure the source sustainability. I should recommend that we should think of the taking up these two challenges. One is a source sustainability, second is a use of the solar system, third is a O&M sustainability in a mission mode, right? So poorly conceived system design result the inflated capex. I will give a demonstration things how the guidelines have been misused by the at national level. Then that can be corrected with the proper capacity building examples. And multi-village water supply scheme in the JJM has got a lost priority. But the most of the states, without thinking of the problem, they have switched out the multi-village water supply schemes, invested huge amount of the capex. Ultimately, you need a OPEX amount. I am putting an example from the Madhya Pradesh. One pilot scheme I studied, their annual O&M is roughly 7 crores, right? and power bills are roughly 4.5 crores. So you can think of how to impact the solar system here. And if Madhya Pradesh is implementing 200 such multi-level water supply schemes, we need a 2,000 crore rupees annual for the annual O&M. From how this money will be coming? This can be given a second thought. Without that, you cannot maintain that. Thirdly, poor maintenance, because ultimately we are targeting sustainable maintenance. Asset deterioration is a major challenge. Water quality monitoring surveillance, already JJM has talked in the new guidelines, has to be taken care of through IoT-based system. I will not recommend the SCADA system. Already JJM guideline has a good job to develop a IoT-based measurement monitoring system. I can show you one example. If your service delivery is not assured, community will not pay you the money. So, thirdly, the major challenge is environment impact assessment is missing. If you are giving a drinking water supply, maybe 135, maybe 70 LPCD, but by return, you are getting wastewater about 70%. So we should need to have a drainage, appropriate drainage system and disposal system. Otherwise, on one end, we are claiming the portability of water, on other end we are disposing the water in the village or town in small pools, rather creating a problem for the health. Next. So basically, based on the discussions, so I will be talking on the strengthening of source sustainability infrastructure decision against the climate risk. One is protecting the water sources. Theory can be implemented in coordinated manner in watershed management theory. Rather, in technical, I should say it is a catchment area principle, right? Secondly, I have gone to USA where in the Seattle water supply scheme, water supply is through the lake source. They have protected catchment area and ensuring the recharge into the lake also. Thirdly, major challenge in the country, in the especially urban towns, is a pollution control of the water bodies. Need to be think over twice how we can get rid of such thing. The enhancing climate resilience infrastructure. Think of the solar system. What are the durability of pipelines? How we can withstand the calamities further. Again, sustainable water management is a key challenge. Need to ensure the NRW and smart monitoring system, which CPH always talks for. So community capacity is a key challenge here. So we need to have a training and awareness how to ensure operational maintenance by engaging local communities. This is a major requirement of both the program and ultimately climate adaptation and mitigation is the most important in the present scenario. Secure, secure water sources for the future, as SDG suggests, ensure the reliable water services ultimate aim. So, with the background, what I was talking, that we need, because I go through the whole guidelines at grassroots level or CPHO manual, it is not possible to go. So I am going to give, I have developed a summary of the planning and design mark benchmark indicators component wise. I can show you a little glimpse how the things can happen if you adopt such summaries. So I will be developed by the planning DPR, and I can also validate the DPR prepared by the consultants. I will give a glimpse of the component wise. See what the guidelines suggest 30 years. Okay, everybody knows. But think of the useful life of the each component which has been defined in the CPHO manual. Unfortunately, I have validated thousands of schemes which are based on the impounding reservoir. I have never seen the source has been considered for the 50 years as recommended for the as recommended CPHO for the 50 years. This is a major challenge I have seen, maximum 30 years. Secondly, we should consider planning period in consideration with the availability of resources, which is most important. What are the funding agency requirement? Effective service life of each component. Here, I have some reservations regarding the rural water supply schemes. Is it really a correct thing to adopt 30 years for the rural water supply scheme? Most of the international guidelines suggest the rural water supply life should be restricted to the 15 to 20 years because mostly these are based on the groundwater sources, and groundwater sources life is under the problem, depletion of groundwater, reduction in the yield. So we can think it over twice planning of the rural water supply schemes. Otherwise, my infrastructure will be under the stress conditions. So mostly, secondly, especially master plans. I am talking about urban water supply scheme. But what master plans has a limitations. Maybe for the 5 years, 10 years, 15 years. Say, taking example of Bhopal, I will explain you how the things are happening. I will show you. So limitation of master plan also impact your the planning and designing of the system. Most of the designers, what they do, they try to put whole of the population in the master plan area. They never think what are the future plans because they don't have any problem because my decision making should be in the considering the future expansion also as CPHO will suggest. Further, I need to ensure the existing water supply status before planning of the water supply scheme. Further, major challenges the decision making or demographics. I can discuss in future. Next slides. Next. So these are the basic. Next. So what the CPHO and JJM guidelines suggest, this is the water supply level as defined by CPHO and JJM guidelines. But water is a state subject what you are talking. Water supply level can be modified. If in a village or habitation, if my source is not capable of delivering sufficient water, so I can think of that giving less water quantity. This can be decided by the states. So this otherwise what happened, most of the states are planning, designing on the above mentioned water supply levels, but community is not, and infrastructure has been designed accordingly. We are spending money, but availability of water is a major challenge. It is a source feasibility as recommended in the CPM. It has been adopted in 90. Is it correct? I have put a question mark. Out of 100 years, my source dependability 95 years is not feasible, and it has been recommended in most of the guidelines that 95 is not correct, should be 100%. Think it over twice. This is my suggestion, and most of the projects I have designed on this theory. And previous knowledgeable speakers in this past, they have talked about the 100% dependability of source for the drinking water. So again, I defined how, what are the data required for the planning and design, or if a source is a river, source is whether it is a perennial, what are the ground depletion rates. So I defined everything here. Okay, or if you use HGM maps, I can define. So this is a major how to identify source using HGMS. I can show you example. So source sustainability measures such as conservation practices Water harvesting should be made mandatory. Groundwater recharge using the hydrogeomorphism measure. I will talk on later stage. So again, these are the key requirement how selection criteria intake systems for the drinking water supply scheme. And basically, I have highlighted most of cases permissions are delayed, which further delay the implementation. So again, it is a whole the what are the key requirements planning of the intake system has been defined very clearly as per the guidelines. Only these are the summarized here. You can take advantage of that. Okay. So again, major issue is planning and designing of transmission main. Maybe raw water, maybe clear water. You can have a walk on different alignments to identify various alignments on the topo sheet. What are the issues of each alignment, and accordingly work out the life cycle cost approach thinking, and which can be a better option. Initially, maybe capital may be a little higher, but O&M may be a cheaper rather. So we need a appropriate topo surveys. We need soil properties further, because if selection of pipe material without soil properties, you cannot select the pipe material. Quality of water is a major in decision making for selection of pipe material, right? You need a metallic or non-metallic. It is as per CPH manual metrics, you can decide the selection of pipe material. Next. So again, prerequisites are defined here for the selection of pipe material. Next, next. So one back. So mainly I have mentioned here use of duplicate pipelines, especially in the metro cities. Refer the CPHO manual planning guidelines where you are using the MS pipe, because MS pipe under the suction condition go under compression, so it used to damage. It has been recommended by the CPHO manual. Think of provisioning of duplicate pipelines. I used in this theory, I used in the planning of the Raipur water supply scheme very successfully. Next. So again, well, how to use design procedure is defined. Hazen William has been recommended mostly as per CPHO manual. Uh, an accurate estimation of C value recommended. Everything is defined very well in the CPHO manual. Next. So one thing I want to keep, CPHO manual C value has been defined in standard practices. Further, CPM also suggests there is a progressive reduction in the C value, considering the soil conditions, considering the water quality, other factors. Even C value has been reduced by 37 to 74%. It is mentioned in the manual. So decision making of adopting for design purpose C value is as per conditions, and it is a designer's. Thirdly, in the planning of CPA convincement, designing, minimum and maximum electricity has been defined. Maximum not issue, but major flaw I observed across the various states, considering the zero point 0.6 meter per second that is required to prevent the sedimentation, meter to 1.3 meter per second. Further, minor losses is a major issue. I will talk on the stages. It is varying because CPH module suggests 5 to 7%. If I am working in the hilly terrain, you get lot of turnings, dips, etc. You need a more and more and more fittings and walls. So naturally, my losses will be more. So it is as per site condition, right? Next, again, to account for other losses, 5 to 7%, but decide it as per site conditions. And by thumb rule, if you do not want to calculate the water hammer through the calculation of the formula, simply as defines the CPHO manual. By thumb rule, it is a 90% okay, 125 times of the ultimate velocity you can design, and residual pressure should be kept around 3 meter at terminal pressures. Next. So again, this is a mentioned CPHO manual. Next. So again, it has, as per CPHO manual, standby arrangement of pumps has been defined. What is required quantity. So as this is defined 25 mld for small water supply system, medium and larger. So accordingly, you can adopt the standby systems as per suggested in the CPHO manual. Next. This is again a design of the pumping system. Uh, Most of the designer does not consider the motor shaft losses and margin for power motor. Roughly that comes about 12 to 15%. If my I designed a 100 HP of system, but need to consider that these losses may be 115 HP. Next. So water treatment as defined here. So design consideration suggests the 5.5 km per hour, but in no case it should be more than 6 km. So losses of sludge in the flocculator and backwash filtration has been limited to 3%, but reality is. In earlier CPH manual, it was a 7 to 8%. Okay. And we can collect this water, recycle, reuse of the backwash water into the system bed. With that, we can uh, take the advantage of the water conservation. Further, slow sand filter has been suggested, which is the best option for small water supply scheme. In the present scenario, 99% schemes are based on the refrigerator filters, whose O&M cost is huge, and it is not advisable for the community water supply schemes. The issue with the slow sand filter is stringent input water within 10 to 20, and previously we used to adopt the simply sedimentary tanks, which are not capable in the present scenarios. So we can think to provide a roughing filters in addition to the conventional treatment system. Next. Next. So mostly master buildings reservoirs are used mostly in the urban water supply schemes, where 3 hour detention period has been recommended for the ultimate water demand. Okay, next. So this is all the things has been explained as per CPHO manual. You can take advantage of these guidelines in brief. Next. So here what I have managed in the small water supply schemes, you have got 4 pipes: outlet, is cover, overflow, and firefighting. For the community water supply scheme, if you put a coloring system on the pipeline, so he can identify that which pipe is for what purpose. Next. And secondly, recommended mesh screens for the outlet and scour pipes. In the I got a study about 20 years back of pure water supply schemes, where local body engineers have gone into the container, the order tank. They tried to clear the scour pipes. Wall, luckily, wall was open at the bottom. Suction created, and 2 person has been uh, slipped into the scour pipe. Luckily, pipe was open, so their life was saved. So always try to put a mesh screen above the outlet and scour pipe. Next. So these are defined as per situation manual. I won't go further. Next. Next. Everything is mentioned as per CPHO manual. Need not worry. So this environmental impact assessment has been mandatory. I applied a one water supply scheme for multi-village in CD. Source was River Banas. In the upstream, there was a sanctuary, and the downstream there was a Gharial sanctuary. So wildlife department taken objection. We had taken care of things, but project was delayed for 2 years. So think it were how the EIA should consider all the conditions. Or EIA basically what I was talking, wastewater generation is a major challenge the water supply seems. Next, so costing as defined by the state departments with their SORs, they can work out accordingly. And mostly urban water supply talks for the robust SCADA system. Really is it is economical. What are your requirements? How we can think for that? So I think under the condition, JJM guidelines has done the excellent work across the country. They have prepared one roadmap for the IoT based measurement monitoring system, and they have defined where, under what condition, which IoT system is required, that is only on GSM based. Simple, easy. So, so it's because my experience, the Punjab water supply systems suggest that huge crores of rupees is being spent on the SCADA system, but functionality is a major challenge. Next, annual O&M, I have defined here as per guidelines. Two things are missing in the O&M estimation. One, a depreciation cost for the electrical mechanical equipments, and loan repayment. If you are taking a loan, need to consider the loan repayment conditions. Accordingly, cost of protection of water has to be devised, right? This is the most important issue, which is mostly missing in the projects. Next, so again, as suggested, recommended by both guidelines, adoption of solar energy, which is the most important. We'll be talking next on, and water tariff. And I am coming back to main presentation. Next, so here, as per guidelines and CPHO manual JJM requirements, performance banner indicators has been defined. This can be changed as per state specific, can be further updated because water is just something I am. So number one, water quantity is decided by demographic studies and per capita water supply and other water demands. Okay, very clear. Source dependability 95% as recommended in guidelines, but I am opinion should be 100. Water quality of the water quality should be as per GIS 1050. Pressure for the JJM it is 7 meters, and for the urban class 1 and class 2 cities has been defined that should be taken care of. Non-revenue water should be limited to the 15%, which is the key consideration here. Household coverage with the protected water supply should be 100%. Sustainable by capacity building. Sustainability O&M can be achieved by capacity building or local bodies of PRI. This is the most important topic, and we will talk how the things can be taken care of. Affordable O&M, we were talking, the revenue should be more than OPEX, but reality is otherwise. We will think how can we can. So we need to ensure how to generate the more revenue or how to minimize the OPEX. Complaint redressal as recommended CPHO manual. And finally, regularity and sustainability. Ensure the water service delivery. Refer my initial slide. The key, ultimately, our aim is how to ensure water service delivery, that is reliable water service delivery. So we need to have a sensor-based measurement monitoring system, functionality around the year, 365 days. So I am insisting very much until unless you have the data, real-time data of the field, you cannot. Number one, we need administrative maps of the area, master plans showing specific feature. We need a hydrogeomorphic pair, HGM maps and topo sheets and drainage maps, census data, right? And georeference mapping of the all the existing water supply component, which is the most important. Also talking for the NRW there. What the pipe material, existing pipe material is there, which is they're aging because Indore suggests that it was augmented 20 years back, so pipe is not properly using now. So we need the aging. Now, one thing I added, proximity to the drains, sewers, and overall reliability. This is a major challenge which is coming from the Indore study. So, in the next thing I have mentioned, because this is not mentioned in the CPHO manual, existing sewerage system, its functionality, right? I need to ensure, apart from my existing water supply parameters, water quality parameters, I need to assess DO, POD, and COD to identify the contamination locations. This is a major, this has been recommended in the CPHO manual now. This chapter has been written by me for the CPHO. Next. So it was a sewage, and I am talking of wastewater and solid waste also. So BOD, COD, I already talked. Water quality impact on groundwater bodies due to the disposal of solid waste, that is landfill site. This is a major challenge. Okay. Will show you the Bhopal case study where Adampur, due to our whole watershed has been contaminated, right? Then mapping of the industrial pollution points. As you can map all the industrial pollution points on the GIS maps. Again, one thing more, in most of the towns, small, big hospitals, health centers are coming up. What about the hazardous material? Can you think of that? Mostly they are disposing in the nearby area, might be leaching, might be containing the other water bodies. So it is a major challenge. Think it over twice. These are the challenges, upcoming challenges, right? Okay. And finally, you mark the pipelines running below the sewer pipelines, running ac- across the wastewater drainage. This is the most important while collecting the data. What is the power availability, what present water supply. So you can collect until you cannot collect data, you cannot plan the appropriate sustainable system. Next. So I developed one matrix. You can take this matrix. I have given the things. What is the present status? You can mention here. What are the gaps with reference to the benchmark indicators and guidelines, and put a remark. So you can have a study of the existing system and deficiency. Next. So once you have developed the existing water supply scheme, shortcoming gaps, so you can define what is the need of the project, how I can go further, whether I need a retrofitting a system, whether I need an improvement of system, whether I need a rehabilitation or augmentation or need a new system. Once you work out that matrix, you can analyze the data and accordingly decide the things. So especially I am coming in the bottom as per JJM, they are suggest a three type system: single village system, multi-village system, and solar based version. So based on that, you can think of that. So this is a well-defined planning process of water supply scheme. We have seen planning and design benchmark indicators. We already seen. baseline survey already seen. We need a right from the initiation of water supply system. We need a IEC and capacity building system in place. It should be a target oriented requirement. Mapping of the exit water supply system we have seen again analysis. So most of things we have talked for. Here I have put a transact cost. So that's I'm talking about the fixing alignment of the pump. So the pumping main. Then coming to once I have decided to take up the job planning, my first job is to identify the sustainable source, and its studies are needed. We had talked about the things. So finally, once I had selected the source, I should go for the topographical survey for the village, town, whatever. Once my survey is completed, I can prepare a detailed drawings based on the survey. I can go for the different hydraulic designs, maybe pumping main, maybe pumps, maybe WTP distribution, whatever. Then you develop a DPR and review it first. Whosoever is reviewer is there. Once if I am developing the DPR, I need a third party validation. So whatever shortcomings are there, I can update and accordingly approvals can be thought. Then sanctions, right? So I have clearly mentioned quality control coordination protocol during implementation, which is very much missing, can be developed first, then tendering procedure. Once my project implemented, I need a testing commissioning system. Then comes operation maintenance. Asset management, mapping is the most important, which JJM is now insisting upon. Before handing over to the local bodies, we should have a asset mapping so that it will help you out in the sustainable O&M. Simultaneously, it is a part of O&M, water quality monitoring, supported by IoT-based measurement monitoring system to ensure the service delivery. This is the process complete. Next. So, as I talked, this is a case study of the Bhopal master plan. See, in 2005, my population was 16 lakhs. As per master plan 2031 is around 36 lakhs. This is a master plan boundary. Okay. If I today design a system for Bhopal, my population, likely population, this is roughly I have estimated 55 lakhs. Considering the FAR conditions, other things, the present master plan area can accommodate only 40 lakhs of population. Where I to accommodate the balance 15 lakhs? This is a designer to think. He has to talk to the various agencies. How the so my planning should be limited to the 40 to 40 lakhs population. I should not spend the money because most of the design, what they do, they design the distribution pumping main put within this area. This is not correct. So I put a not feasible. Okay. So I already discussed. CPH manual has been also adapted for the JJM guideline, 30 years. But again, my thinking is that being a groundwater source, rural water supply scheme should be planned for the 15 to 20 years. Next. So my key focus point is reliable water service delivery over full design period. Here I am what talking of this also CPHM is also recommend and JJM also recommended. We need a robust infrastructure, reliable pipes, pumps, and reservoirs. Right? So accordingly, we need to design adequate water supply, sufficient source, and storage. Major issue is lack of skill persons in the operations. So we need a capacity building, right? Effective monitoring, which we talk for the water quality as well as water service delivery. So I had defined what should be a design period, maybe 10, maybe 20, whatever may be. So it is a designer to decide and need a clarity in the guidelines in the what condition we should adopt, and we should be prepared for the emergency and climate problems. We'll be talking on the source security because source sustainability and security two are the different things. But more 99% people feel that it is a one and same thing. It is not a one and same thing. Next, about few days back, I was going through a one article of the World Bank. They are talking water bank substancy. Few towns, it has been warned that Indian towns are also facing such problem. Second article, which I am going, are we heading for day zero? Yes. See the Chennai. If we are not thinking for the sustainability of the drinking water sources, we may face such problems in future, considering the climate problems also. Next. So now, think it out twice because we are the water users. How and we are the water providers also as the engineer. What we to do? Think and rethink. This is our job. Next. So solution ensure overall system. I am talking about overall system sustainability. Think source sustainability is a single thing. So I will explain what is the overall system sustainability. Here, as conceived, we are talking community center. We are the technical support engineers are technical support agencies. Keep it in mind. Institutional arrangement by developed by community is a part of the community. Number one, I am talking about the source visibility, right? Quantity and quality. I need this quantity quality in consideration with the SDG 6 for the full design period without compromising the future generation. This is the most important. Once I achieve, so what is required? I need a sustainable source and how to ensure the sustainability of the source. Two things: system suitability. This is a here designer comes in the picture. What he conceives, what he want, what type of scheme is required should be governed by the techno-economic feasibility. Right? I can give you example. And second important point while execution is quality assurance and quality control. On site, ऐसा नहीं है कि हमने एक सैंपल ले लिया भेज दिया साहब वो तो हमारा हो गया. It should be a regular process on the site, right? So operation maintenance sustainability is a major challenge. Once we plan, design, and implement and hand it to the local bodies, number one issue is local by PRI does not have a sufficient staff to operate and maintain. Secondly, they don't have a much skills. Even one sub-engineer is operating the whole system, which need to be rethought, and how local bodies are to be supported. And second, capacity building, regular capacity building is a must for them. And social environment integrity is a major challenge. If community is not taken care of properly, the use need of the potable water. Again, affordability is a major challenge because already system is to be managed by them. So environmental condition, what I was talking also, should be taken care of. So these are the four pillars of the sustainability I have explained you. So I had divided water supply in the just like a human organ. What is the heart of the water supply scheme? Heart of the water supply scheme for the community management and monitoring is community-led institutional mechanism in place because governance by the community is there. We need a IC capacity building and sustainable water supply management has to be done with transparency, accountability, corruption-less, and sustainability on the top priority. Next, then source of the water supply is a soul. If your source is not there, no sustainable source is there, you cannot talk for the scheme. So ensure the source sustainability through water harvesting, managed aquifer recharging, and other processes like roof water harvesting and catchment protections, etc. So further, I define 4R principle: reduce the consumption, recycle wherever necessary. I can give you example. Just in the previous slide, I talked for the wastewater and sludge generated from the water treatment plant can be recycled and reused. So here, water content again, what I'm recovering there, chemicals. So this is a fine example of the in the water treatment plant system. If I got 500 mld, so you are putting a wastewater about say 7%, 35 ml you can recover please rice. And further, whatever sludge is generated, you can use it for the uh, mm, manure development or brick pad development. This is a circular economy theory. Next, then body of the water supply, that is infrastructure. We were talking pipes, pumps, treatment. So accordingly, we need to plan properly based on the key performance indicator. Planning should be optimal. Selection of appropriate pipe material and treatment system. As we discussed, quality control and assurance play a major and vital role. Next. So further, brain of the water supply, operation and maintenance. Whatever we design, ultimately, if I'm properly operation maintenance is not there, so there is a no use of development software. So develop a crisp O&M manual. JJ means taking care of. But further, I think my suggestion is that JJM should come forward with the national guidelines supported by the local inputs. So detailed documentation is required, capacity building regular, training and skill development right from the planning stage is most important to how to manage and operate the water supply system. What are the issues and challenges coming so that my local skilled labor can manage it, right? Ensure timely availability of O&M. This is a major part. Most of the rural water supply scheme, you will find that, sir, we don't have a spare parts. So water supply scheme cannot be managed. So this is a key requirement. Integrating the solar energy management power base. So I am talking this is a because I am insisting very much so the government is also insisting the use of the solar energy and generate willingness to pay among the community through IEC, which is the most important. Next, so health of water supply, water quality and service levels. If water quality is not good, ultimately you are at the risk. So I need a mapping of wastewater drains, disposal treatment. I had discussed sensor-based water quality monitoring surveillance, monitoring and evaluation of the waterborne disease, which is the most important here. We can talk, we can collect the data. What are the problems? What are the previous problems after implementation of water supply system? What are the status of waterborne diseases? So, talks very much for everything, but what are the issues, what was the unaddressed aspects remaining at the field level, lack of technical know among the planner designers, inadequate exposure to the innovative technologies as recommended in the guidelines, and field experience among the planners is the key. Lot of consultant does not have the field experience. If I talk, sir, I got a lot of feedback. Sir, we have waited the scheme from the NIT. Has the professor worked in the really in the field? Because this is a coordination between the field and theory. So I need coordination between the colleges and field so we can develop such things. So capacity building, lot of things has been talked in the JJM guidelines. They are developed KRCs, but KRCs even does not have a persons to have a, such knowledge to disseminate the things. So this has weakened the institutional preparedness, right? So in the absence of IECF, willingness pay has is facing the major challenge, especially in the JJM and small towns water supply schemes. Several schemes planned without adherence to the norms and guidelines, lacking technical feasibility. I can show you few examples what the CPH manual says, what the JJM guideline says, but DPR prepared not accordingly. Community not consulted, already I talked, because this is a key requirement for the both the program that community need to consult it, even planning of the schemes. So in the JJM guideline, village action plan is a key there, but they were given the only on the paper such things has been developed. Really in the field they were missing. So as I talked, cluster based something new cluster water supply scheme should be given for the ultimate sustainable localized water source. This is something new. What I am talking here, rather going for the huge MBS until unless it is required. If I can get a sustainable source within 2 to 3 to 4 villages, think of that. Are some innovative practices. Say, I some small stop dam under recharge procedure. Go for deepening process. Have a sufficient storage. Put a collecting chamber. Have a roughing filter and pump it. You can develop a 2 to 3 village water supply scheme. Why I am thinking about a regional water supply scheme for whole district, which is a challenge for the sustainable OND. Next, further norms and guidelines have been clearly defined and measurable. What I am talking, outcome oriented, as currently lacking. Example I am putting, JGM recommends the use of HGM maps. Okay, number one for identification of sustainable source and identify recharge structure. That is the only mention there. So I am of opinion that if we are putting the new technology, no technologies, we should come forward with a detailed framework, this planning framework, design framework, implementation framework should be come for that. Okay. Further, Jal Shakti Abhiyan guideline recommend the augment and rehabilitation action. Really, it is a good suggestion, but in they not receive the adequate attention, especially in the urban towns. Most of the water bodies in the urban town has been, I say, uh, their size has been reduced due to the various reasons. Uh, so we can, if we take a scientific approach here, I should go, example, take a help of the GIS based remote monitoring system. I can prepare a mapping, say for 1980, 1985, 90. So we can define the what is the encroachment there happened there. So here I need a political will to remove the encroachment. Desilting and dredging is most appropriate to rehabilitate water bodies. This is really a good suggestion. I appreciate the Chak Abhiyan process. Then water budgeting is a key for the critical ensure long-term sustainability. Drinking water has got the top priority, but Indian context, without giving thought, we are thinking how to process, how to go for the agriculture production much, and even summer they are facing the drinking water problem. So water budgeting has to taken care of, right? So I am coming on the water security. What the water security is? If my source is under the vulnerability, this is a key. Say under drought conditions, say under flood condition, my one source is not functioning, I need to have a supporting water source to get the minimum water supply, at least for the drinking and cooking. So this is defined. Yeah, it is very well mentioned in the Rajiv Gandhi guidelines what the water source security is. Secondly, source safety is a paramount. So we need to have regular source safety incident as defined in the WHO guidelines. It is very clear. We already they have given a template, but this require a regular inspection. Maybe lot of houses are coming up. Okay, their wastewater might be leaching into the sources, maybe water bodies, maybe groundwater. So source safety is a paramount. So most important thing is while planning, the even implementer does not think of the what the safe yield is of the groundwater. Okay, safe yield is can be given, can be worked out through long-term step drawdown test, and further design and yield can be defined considering the summer yield, and accordingly factors can be developed. If present safe yield is, I say, in the month of October is 10,000 LP liters per hour. So by Thamba rule, I used to consider zero point 0.6 or zero point 0.5 times of this. Okay, so safe yield and design is entirely different things, which is not given proper appropriate inputs accordingly. And water safety plan available. So I am talking here. There are three types of the solar system. Standalone, you can use it for the small water supply system, maybe population up to 3 to 400. Hybrid solar system, it may work on solar in the daytime and can operate with the power on the night. And here, I very clearly defined it. In case of solar system, safe field has to be considered in consideration peak sunshine hours. At least I have seen number of water supply scheme in the few states. They used to consider the yield, considering the pumping hours, 10 hours, 12 hours, 15 hours for the solar design. Average in the Indian context, PSH is varying between 4.5 to 5.5 hours. You can work it out, you can search it out. For Bhopal, it is roughly 5 hours. So accordingly, if got a 10,000 liter per day demand, so divided by 5 hours, I need a safe yield, safe design yield, 2,000 liters. So this is a key requirement of solar. Optimal planning and designing is the most important about supply system, source to consumer. Okay, I can show you in the illustration. Adoption of innovative technology is being neglected, although it could significantly enhance the sustainable operational maintenance. Effective operational maintenance pumping system, which is a major challenge. I will show you one example really how you can minimize the water resources and power resources. Okay, swabbing, as advised in the situation manual, I have never seen in life. Yes, swabbing is taking place, but otherwise, pipes are required to be swabbed every 4 to 5 years to clean the pipes to enhance their pipe carrying capacity. Strengthening on-site quality assurance is the most important. How we'll take care of, we'll see. This can be thought of nowadays. It is a digital system era. So on-site digital instrument could be provided practically or effective means of ensuring consistent quality performance through the implementation process. So ultimately, I am coming to water services. Already I have talked sensor-based monitoring system, and finally we are talked. We need to develop a GIS-based asset inventory. This paper was practically presented in last India Water Week by me and Secretary PHE Rajasthan. These were things which were missing rather. What I feel what is required at top level, we need to develop a protocols, SOPs, and framework for the use of the HGM maps. If we are we have to take advantage of the scientific approach for source identification and identification of recharge structures, water footprints. This is the most important point coming up in the latest technologies. Only you think I am get one person is using the 150 LPCD. Is that true? Not. In Indian context, water footprints has been worked out roughly 2000 to 2500 liters per head per day. So what how we can conserve the water? How can we minimize the water? So this is an important point. We need to come forward in the guidelines should include water footprints and its minimization practices. Thirdly, nature-based solutions, right? Water conservation practice, wastewater transportation localized with the localized systems, treatment, simple treatment aerations. I can show you example and disposal, slow and filter roughening use. These are the nature-based solutions. And recharging, you can use the local material and local guidelines can local innovative technology can be used. Source security and sustainability. We already talked the 4R principle. So here, what I am talking, water says on extraction groundwater. Already in September 2021, Ministry of Jal Shakti has issued a one circular implementing water cess for all the purposes. Even this can be used for the extract groundwater for the drinking water purpose, industrial water purpose. So, and that amount has been recommended to use for the groundwater recharge. So further, what I suggest that we need a strong legal framework to use that guidelines mandatorily. Adoption of circular economic practices. is most essential in sustainable water resource management. They should be embedded rather in the drinking water in integrated manner. Say what I am talking, drinking water A. I have shown you, given you example, recycle of the treatment wastewater. Two, you can use the wastewater generated, dispose it after aeration, and can be used for the irrigation purposes within the BOD and COD. I, it is possible, so you can generate the money also. Solar, solar to reduce the energy cost. Okay, net zero practices minimize the life cycle of carbon emissions. If we are putting the solar energy, so I can go towards the net zero practices. Waste to energy is most important here to include, right? And important point to consider hospital waste disposal. Otherwise, this is going to be a major challenge across the country. Water quality monitoring through government agencies, it is there, but in the JJ Task Force meetings, which I was member of their national task force, we are recommend suggested we can take the help of the private health centers at rural and urban levels to develop their water quality monitoring and surveillance labs. This may be a most cheapest option. Next. So risk mitigation and management practices are important in the comprehensively considering the your what are the risk with the water supply system and how to minimize them. On-site water quality monitoring system assurance we will talk. EIA framework should be embedded compulsorily. And finally, what I wanted, there should be a guidelines norm on the regular water audits, say NRW, etc. But there should be a clear-cut format. What data I have to collect, how I can identify the problems, the energy audit. I need a energy efficiency system. I need a solar system. Water safety audit, which is most important nowadays. Social audit. Now, all these things are related to the social audit. So ultimately, consider above, now new era is coming that environmental social governance tools which can measure the sustainability of the system. So this should be rather embedded because drinking water is connected to environment, social community requirement is there, and governance part of there. So I need to embed the ESG systems. Next. So here we should talk for the corporate social responsibility is the most essential in carrying out the sustainable water supply system, especially source sustainability should be taken care of them. So we can think of that. Finally, legal framework to restrict the usage of treated water. If I am getting water from the say municipal water supply system, using the water for car washing, using for gardening, use of floor washing. So we need a legal framework to restrict the usage of water. Maybe volumetric basis, but this is feasible. To my career studies, metering system may or may not be a feasible to my opinion. Next. So coming back to the illustrations, what we are talking, this is a HGA map got developed by the ministry. I am putting a one example. This is a village, Kotni district, Raipur. Earlier in the village, we are having 14 tube wells. In summer, water transportation used to take place. Here we have taken the HGA maps at the scale of 1 is to 10,000 provided by the ISRO. And with the study of the geological features, and aquifer characteristics. Further, we identify the geological fractures, faults, and lineaments. We have identified the tubal location as shown about 2.4 kilometers away from the village. And we have drilled the tubal up to the depth of 60 meter, right? And we have got the safe yield of the 16,000 liter per hour. For last 2 years, we are running the water supply. Pump has been installed to pumping the water for the 12,000 liter per hour, and sustainable water supply is running there. Further, to ensuring the source sustainability, you see here source sustain structure boulder check come die, because this is on the confluence of the two lineaments in the downstream, right? And my pupil is right on the bank of the some rivulet, small nala. So in the upstream, it is recharging the thing. So you can take the help of the scientific approach. This is defined disciplinary. So we have developed a process with the help of the ISRO. We have conducted studies in the two villages where Director ISRO and uh, this Chhattisgarh Science and Technology Department and hydrogeologists were available. And further, once we have cited the tubal location on the this AGM map with the lat long, we have transferred it to the ground, right? And further, ERT geophysical studies were taken care of, and then we got a successful tubal. This has been adopted in two villages of Chhattisgarh, and we got 100% successful. So we have developed a framework for that complete. What is requirement, what the data is required, how AGM map can be read, how field data can be covered. Everything has been developed with the help of ISRO. Next. So again, second part, as suggested in the JGM guideline, identification of the recharge structure using HGMF. Theory is same. So only we need to take the advantage of the further soil details, whether shallow recharging is required or my deep aquifer lineaments are there. So accordingly, if one watershed was planned and developed in the Chhattisgarh at the prior to the construction of the structure, roughly one structure were identified. These are mostly dikes, boulder taken dikes, and one or two percolation tanks were constructed in 2001. Okay, and at that time, water level was 35 to 40 meter below ground level. Hand pump functioning was impaired in the government in the summer, but present water level has come up only 12 to 15 meter below in the summer, as confirmed by the PHED. Next. So basically, what we were talking here, presently, FTK is being used. FTK results are not can be only that is an indicator, but it depends upon your eyesight. I can say, to my opinion, this is a pH or this is a TDS. In others' opinion, they may differ. So nowadays, digital on-site instruments, small you can put in the pocket. You can have a pH meter, you can have a TDS meter, turbidity meter, iron, fluoride, free chlorine, or all these on-site meters are available easily. Which with the training, these can be used simply by community persons. So 90% results are really excellent, and this will reduce the cost of the lab working. Next. Similarly, quality assurance on the site. Mostly, you have to check the pipe, PVC, SDP, GI, water case maybe. I need a hexa. I can cut the pipe. You can measure the thickness of pipe by digital screw gauge or vernier caliper. You can measure the zinc coating of the GI pipe. Then you can check the weight through spring balance. You can have measuring tape to measure the pipe length depth. You can check the mm, strength of the concrete through rebound hammer, magnetic compass to fix the orientation of solar. You can, with a digital degree protector, you can fix the angle of the solar. Multimeter, you can check the all the electric things, and wire gauge to measure them. So these are small things we have developed, and Chhattisgarh is using in few divisions. So this is a monitoring system as recommended by the JJM guidelines. Here we have put a one sensor for piezometer, rather sensor by piezometer to measure the water level daily. Then one pressure gauge sensor at inlet of the overhead tank, and one water meter at inlet of the tank to measure the daily pumping water quantity. Only two other sensors we have used. One is to measure the chlorination system, and at 2 points we are measuring the pressure, that is highest and longest point. So this is a basic requirement. You are measuring the quality, chlorination, you are measuring the quantity of water, why I need? Oh, it is completely a GSM based system, and small app has been developed on the system. You can it give you a warning also. Your chlorine is not measured as per requirement. So immediately you can take care of person concerned, that he can increase the dose, or something is happen with the chlorination, so pollution might be there. So if your pressure problem is there at the fag ends, so there might have been the leakages there. Next. So there are three systems: standalone system for small habitations, hybrid system for bigger village and small towns, integrating solar and grid power, and grid-tied net metering system for regional and urban water supply schemes. So these are basic requirement for planning and designing of solar. So I have put it. One is a system which you see on the left remote corner. It is a new scheme at the with the 1 horsepower system, 1200 WP. But here, I am sorry to say, across the India, lakhs and lakhs of system has been put into the use only one standard system, 1 horsepower, 900 up 1200 WP system. Is it a right? No, because your quantity, village wise, your water demand is varying. Your water depth at each place is varying. So if your horsepower calculation is varying, so your input power may vary. So the study suggests 70% of systems has been under designed, only giving water of roughly approximately of 9,000 to 10,000 LPT per day. Basically, these systems were recommended by the Minister of Drinking Water way back in 2010-11 for the schools and Anganwadis. These were not, nobody is coming to maintain the system, because department has an AMC for 5 years. Thirdly, you see the picture, the foundation, even within 6 months of the construction, foundation has been damaged. So this is a quality issues. What I had. So these are design parameters. What I suggested. Next. So I was talking optimization of pumping system. Normally, what engineers or planners do, say, this is one example. I worked it out. My present demand is say 100 mld. After 15 years, it is 125 mld, and after 30 years, it is 150 mld. Normally, as practice, what we do, initially we install the pump for 125 mld for the first 15 years water demand. This is right, but by what the present demand is there. So here I example put, I considered 20 hours pumping at the end of the first 15 years. So I have worked out the pumping hours. If I am pumping, I have worked out the water demand yearly here. Say 100, 105, 110, 100 accordingly in progress manner. And I have defined that how much operation of pumps should be there to minimize the pumping hours. Right from 16 hours, you see there 16 to 20 hours. So I can reduce the cost of the energy. Secondly, initially I need to draw only 100 mld, then 105 mld, then 108 mld. So why? Because if I'm pumping the system so designed for the 15 years, I am pumping 125 mld of water for whole of the period. So I am also wasting the water resource. So this is a comparative studies given by me, and to how to ensure the optimization of water resources. And so if you combined it, huge huge amount can be saved. Next. So this is a nature-based solution. You can put a simply aeration tank. Wastewater can be collected, aerated, and with appropriate detention period, and BOD and COD can be reduced, and water can be used for the irrigation purpose. Next. So I was talking. This is a real-time case study with this is near the Bhopal, where existing source and filter was functioning with the sedimentation tank. With the time, SSF was defunct because it was not capable of taking care of the turbidity level of the river. So we have decided to add 1 unit of roughing filters. See here. Next. So I have disconnected sediment tank from the SF unit into HRO unit, and with the result, I am getting the required input water, and system was also augmented 0.4 mld to 0.72 mld. So we need to adopt nature-based and innovative technologies. Next. So I am talking of optimal system design as a whole. Normally, in practice, we used to design the system in uncoordinated manner. Distribution separately, height of storage separately, pumping end separately, and accordingly pump. Right? This is a practice. What I have done here, I have developed a system which was presented by me in Italy in water supply conference, was appreciated like anything. What I am doing here, I have connected three softwares: pumping main designs, pump design, and distribution design. I have iterated staging. At one point of the time, I that my distribution cost has been optimized, as well as pumping main has been optimized and pump has been optimized. So this can be a appropriate system for designing to optimize. Even we can save up to the 20 to 30% of the cost with this thing without compromise technical feasibility. Next. So this is a solar based or hand pump based iron system. You can be used. This is a biological filtration system and been piloted in the Chhattisgarh and validated by the NERI. Next. So what I was talking that I need technologies to use the two or three villages. See here, this is one stop them there. You can even, if the sufficient catchment is there, you can have a deep thing arrangement, put a pipe there, put a roughing filter there, and collect the water and have a solar system, and you can pump it to water to village. You can cover two or three villages there, so maintenance will be very easy and simple. Roughing filter with polishing unit can be used. Next. So again, same theory I am here. What I am adapting, it was a surface storage. Here, if I am having a good site where alluvium strata or concur and other strata or sandy strata is there, where depth of the alluvium zone might be 10 to 12 to 15 meters there, I can construct a dike. Number 10, you can see with the polythene lining, right? And I have constructed a one small, maybe tubewell, maybe use a duck well with screens filled with the media. And I am taking the water and supplying it. Next. So already we talk in our plan design water supply system. CPSO में water supply sewerage leading to the increased capital as well as the operation maintenance cost. So what are you talking? People are not planning and designing the guide projects in the spirit of the CPH and JJM guidelines. Misinterpretation of guidelines. I can show you. Example, economical size of conveyance lines is often not properly assessed and pipelines are designed based on the minimum velocity. What I was talking. Say Q is equal to A into V, right? You are working out the area. You are fixing the velocity at zero point 0.6. Discharge is fixed. That's the ultimate. So if I am, and this is what ultimate, say as suggested, if I am designing over 150 mld, if my present water demand 100 mld, the velocity goes down up to point less than 3. So silting will take place. It will deteriorate the surface, and ultimately it will give, if I have gone for the economic size of pumping main, it might have reduced 1.5 to 2 diameter less. So I am rather increasing the cost of the system. Next. So C, number one, this is a one village, Dabar in the Raisen. Under the JJM guideline, GI has been laid in the wastewater nala. What you can talk about the water safety. Next, this is the picture of the indoor system where this has occurred. See, sluice wall is there. It suggests that the pipeline has been laid along the wastewater nala. Then service connection from same line is coming there. So this is a real-time picture of the indoor water supply system. Next. Yeah. चलो कुछ करो.
सर आई थिंक नाउ यू शुड एक बार
Yeah,
कंक्लूड कर दे सर, आई थिंक.
हाँ ये लास्ट स्लाइड ये सर. So basically, this is the takeaway which we have discussed, and what we have suggested. This has been finalized. This is a final slide. Okay. Thank you.
Thank you so much, sir, for this wonderful and exhaustive and elaborate lecture on this distribution system across India, touching all the policies of government sectors, including Jal Jeevan Mission and most of other things, their guidelines. Uh, and I didn't read your biodata because I was thinking it will take at least half an hour to read your biodata. I'm really sorry, sir.
No,
But
no
I
problem.
think listener must have known the vast experience behind your work. I'll just read few questions that has been written in this chat box, and we'll try to brief, sir. I'll read the questions one by one, sir. Kindly allow, sir.
Okay, okay. You can go ahead.
Do we also need cadastre map in data collection phase? One question from Miss Rachna.
Yeah, we can.
One
Hello.
is, yes, sir. We'll go for next question. Sir, presently in India, which state, cities, town, oblique large site projects all are well planned, designed, and implemented under this planning process? Bracket में लिखा है smart water supply system running with 100% success rate, safe drinking water supply, sir. Also, is it possible to stop the bottled package and hygienic drinking water available in the market, sir? थोड़ा सा इस पे अपना व्यू दे दें, सर. Mr. Babu has
So,
written.
any, it is an excellent question, sir. Number one, what I was talking, we need a sustainable planning. So, climate adaptation and mitigation is rather missing in all the projects so far. O&M sustainability is missing so far. So I we cannot say these are so sustainability has been not thought for while planning the system. Number one. Secondly, I am totally against the use of the bottled water. Practically, I spend my own money to get the bottled water tested. Even in 80% of the bottled water, these bottled water are not fit for the drinking.
Okay, sir, I'll take the another questions. Uh,
Yeah,
sir,
yeah, yeah, you can.
can you please cover house connection concept in today's session? कुछ इस पे हल्का फुल्का अगर बता पाए briefly.
देखिए सर, गवर्नमेंट इंडिया का चाहे डीएफटी हो चाहे वो, दे आर दे आर ऑन राइट ट्रैक, नो डाउट। विकास, एक तो क्या होता है, यदि हम राजस्थान को लें, गुजरात को लें, वहाँ माइल्स टुगेदर लोगों को पैदल चलना पड़ता है। यदि घर में पानी देंगे तो नेचुरली जो फीमेल कम्युनिटी है मेरी सर, उनको बहुत प्रॉब्लम होती है। तो एक तो बेनिफिट उसका ये है कि घर में, बट ओनली थिंग इज, यदि इफ आई कैन प्रोवाइड अ सेफ एंड पोर्टेबल वाटर, मे बी little quantity for minimum needs, this is a really a good solution. I recommend that household का मैं एक दूसरी चीज बोलूंगा, आई हैव डेवलप्ड गाइडलाइन फॉर आगा फाउंडेशन, where I have suggested, because their villages are here happy, we used to talk the habitation, but वहाँ पे क्या है, villages are in length, मतलब the villages are located, small cluster the houses are there, दो दो किलोमीटर लेंथ villages हैं। वहां पे मैंने एक सजेस्ट ये किया है सिस्टम, कि सोलर बेस्ड सिस्टम सोलर पे दे दिया है। इधर डायरेक्शन 250 पॉपुलेशन के लिए मैंने क्लस्टर टंकियों का प्रावधान किया है। दिस इज आल्सो पॉसिबल इन द ट्राइबल एरियाज ऑफ द इंडियन कॉन्टेक्स्ट।
I think the next things mentioned in the chat box, financial viability also depends on proper tariff structure. The freebies should be limited. Asset management is mostly absent. Mr. Garimelo Crow has written this. Any view on
And
this, sir?
I totally agree with him. Number one, revenue tariff is governed by political will. Everybody is agreed. If I say my cost of production of water is say 10,000, 10 rupees per kiloliter, but I'm putting example of Madhya Pradesh, Chhattisgarh. They say household connection should be charged only for 100. So it is a major challenge how to ensure the gap funding. तो स्टेट हैज द ओवरबर्डन, तो अंडर द कंडीशन मोस्टली वाटर सप्लाई स्कीम आप देखेंगे डिफंक हो जाती है, चलती नहीं है। इट इज अ मेजर चैलेंज, तो रेवेन्यू इज अ मेजर चैलेंज विथ अस सर।
I think we are in with the queries, and thank you very much for this wonderful topic of today, essential requisite for sustainable planning of drinking water system, emphasis on climate adaptation and reliable drinking water service delivery. I think it's cover wide range of topic thoughts and what things being executed at the ground level, and definitely I think Jal Jeevan Mission 2 has already been launched, and I personally requested many field engineers, those who are working in Jal Jeevan missions, not only those who are also working on the in some PMUs, to attend this session, because I felt definitely the vision of your lecture may guide them to bring something better on the ground. And thank you so much, sir, for giving your wonderful your lecture, your time, the precious thoughts, and the expert vast experience behind this. We are very much lucky to hear you in this today's event, today's lecture. Thank you so much for joining us. And finally, I also thanks to our listeners who are also working in their unique way in their offices, their research labs, and their uh, different kind of engagement with their uh, uh, routine works and institutions. Thank you all who joined us, listened patiently, And finally, thank you, my team, Naveen and Sunil and other fellows, those who have joined and working with us to bring this session so that all can listen. Thank you so much for joining, and thank you, sir,
Thank
Harish sir, for
thank you,
joining.
thank you,
Namaskar
thank you,
and Dada
everybody.
sir. Thank you.